This is General Chemistry, covering the topic of gas, Part 3. There are two aspects of gas, microscopic and macroscopic. In the past two videos, we already covered microscopic part of the gas. We already talked about kinetic molecular theory or KMT and Graham's law, effusions and diffusions. Here we will be talking about macroscopic part, and we will be first looking at ideal gas law. Ideal gas law attempts to form relationship between physical properties of gas, and that result in the formula PV equal to nRT. P, V, and T are physical properties of gas. Let's take a look at the formula a little more carefully. P is pressure in atmosphere or ATM. V is volume in liter. N is the amount of gas in moles. R is gas constant. And T is temperature in kelvins. You may recall R gas constant from Graham's law. Gas constant here and gas constant from Graham's law are simply in different units. That's why the value looks a little bit different, but they are both gas constant. So let's take a look first at each physical properties of the gas. Pressure in ATM. Sometimes the exam might not give you the pressure in ATM, but in different units. But you need to know how to convert it. 1 ATM equal to 760 torr, 760 millimeter of mercury, or 101.3 kilopascal. Volume in liter. 1 liter equal to 1000 cubic centimeter, 1000 cc, or 1000 milliliter. 1 liter also equal to 10 to the negative 3 of cubic meter. For T, it needs to be in Kelvin. And if you have T in Celsius, just add 273 into it to get Kelvin. There is a special condition which is called standard temperature and pressure, or STP. At STP, pressure is always at 1 atm and temperature is always at 0 degrees Celsius or 273 Kelvin. Sometimes the exam might not give you pressure and temperature, but they just give you the STP, so you know exactly what it is. There is also another information that comes out of STP. We call it standard molar volume. Basically, at this condition, any ideal gases at STP, if you have 1 mole of that gas, it will occupy 22.4 liter. If you don't want to remember this, you can plug the information back into PV equal to nRT to get 1 mole equal to 22.4 liter. Remember, first is PV equal to nRT. Second is STP, standard temperature and pressure. And third is that at STP, 1 mole of gas will occupy 22.4 liter. So next, we will take a look and practice some questions here. For this one, what is the pressure in ATM of 5 mole helium gas in 12 liter balloon at 27 degrees Celsius? PV equal to nRT. So you know N, you know V, you know T, and they ask for P. Okay, so that's pretty straightforward. P equal to nRT over V, which is gonna be equal to 5 mole, and that should be 0.082 liter ATM per mole Kelvin, and that should be 273 plus 27, that should be 300 Kelvin. And that's over 12 liter. Okay, so let's try. So that is, this is 3. That is should be about 0.02. And then 3, that should be about 100. So that should be approximately 10 liter. And if you actually plug into calculator, it should be about 10.25 liter. So sometimes if you want to approximate, it will speed up the process quite a bit. So for these questions, nitrogen gas in 34 liter tank at 273 Kelvin has a pressure of 1 atm. How many molecules of the nitrogen gas should be found in the tank? Alright, so let's see what we know. This is V. This is T. This is P. And here they want how many molecules. So it's not like as straightforward as the last one, but we should be able to use PV equal to nRT. But before that, you should notice that they give 273 Kelvin and 1 atm. That's actually at STP. So basically, to get number of the molecules of the nitrogen, you need to know the mole first. So there's two approach here. Approach 1, you can use PV equal to nRT. And then you can get N equal to PV over RT, which is going to take you some time. Or approach 2, STP. They give it to you already, and we know that at STP, 1 mole equal to 22.4 liter. So we can make use of it. Let's try that. So we know that 1 mole have 22.4 liter. So how many mole would be for 34 liter? So N gonna be equal to 34 over 22.4. I just approximate it. That should be about 33. That should be about 22. So we should be able to get mole to be 1.5 mole. Alright, and from here we also know that 1 mole actually have 6.02 10 to the 23rd molecules. Actually, it could be like also atoms, ions, or whatever you need. But it has to be 6.02 times 10 to the 23rd, and in this case, molecules. So we know that 1 mole gonna be equal to 6.02 times 10 to the 23rd molecules. So how about 1.5 mole that we just obtained? How many molecules? That is pretty much like 1.5 times 6.02 times 10 to the 23rd. This is actually about 6 times 1.5, so you should be able to get about 9 times 10 to the 23rd molecules. And that is the answer. if you have calculator and if you plug it in, 1.52 mole, and that should be from calculator to be 9.14 times 10 to the 23rd molecules. Yep, they are pretty close, about the same.